walk you through all the steps, right? So in the first step, you're balancing a reaction. Now, do you know what it means to balance two sides of a reaction?
Make sure like the number of, I guess, like molecules.
Yeah,
are
exactly.
equal on both sides.
Yeah, you want to make sure that they're in equal quantities on both sides of the arrow. In this case, you want to look at what you already have on the left side first. So you have C6, H12, O6. Now, between the elements that you see in this group and the same elements on the other side of the arrow sign, are they in equal quantities, or do you see something off? They're different,
Yeah.
right? Which ones are different specifically? Everything else looks good. Now you want to determine the oxidation numbers. Okay, so the first thing I would do, right? I would look at the element that's in its natural state first. Which of these elements are in its natural state? You can look over here if it would help. Exactly, oxygen. And what do you know about the oxidation number of something in its natural state?
Is it 0?
Yeah, it is. It's going to be 0, right? So in this case, oxygen is going to be 0, and H2O, all of it together is going to have an oxidation number of 0, right? Because it's a liquid. Now, nothing else seems. Oh, and carbon dioxide is a gas, so the whole thing itself is going to be 0. Right now, you can look at individual oxidation numbers, such as in glucose. So, between these three elements, carbon, hydrogen, and oxygen, which one should you look at first?
Oh, hydrogen.
Right, because it's group 1, right? So, what do you think the oxidation number would be for hydrogen?
Plus 12.
And how many are there?
12.
12. So, you could say that it has an oxidation number of plus 12.
Plus 12, yeah.
And I would write that under the group, just so you can focus on individual oxidation numbers over it. Okay, so now you look at, what do you look at next after hydrogen?
The carbon. Well, no, the oxygen.
Exactly, yeah. I'm glad you caught yourself. So I would look at the oxygen, right? So now you have plus 12, and you know that oxygen has a oxidation number of,
Minus 2.
right, and has a number subscript
6.
6. So 6 times negative 2, you come up with minus 12, right? So now you have a plus 12 charge and a negative 12 charge, and they kind of cancel each
Yeah.
other out. So what can you assume is the oxidation number of carbon?
0.
Right. Now that you add all the oxidation numbers together, you should get 0, because the entire thing is neutral, as it is. Right? So now you have that. Now you're looking at oxygen, which you told me is 0. Right. So do you know what Leo GER is, or oil rig?
He talked about it.
Yeah, a little bit, right? They're just acronyms to help you determine what's an oxidation reaction, what's a reduction reaction, right? So in this case, you have all the individual oxidation numbers, right? So which compound do you see gaining electrons or having a charge go down, and which element do you see losing electrons?
So the carbon goes from 0 to positive 4, so I said that was oxidation.
Yeah.
And then the oxygen goes from 0 to minus 2.
Right.
So that's reduction.
Exactly, because it's going from a higher number to a lower number as you add electrons. So that would be reduction. Perfect. All right. Any more questions?
And then why does this reaction occur spontaneously? Is it because it's producing? Is it because it's a combustion reaction?
That's part of it, yeah. I'm glad you noticed that. Combustion is when you're adding oxygen to a species, right? So it is a combustion reaction, so it's spontaneous in the forward direction. And also, it's a reduction oxidation reaction, right? So when you're losing electrons and gaining electrons in a balanced form, it's going to proceed in the forward direction, right? It's going to balance itself out in that sense, right? But I'm glad you noticed it's combustion. That's just one of the things that could, propel a reaction. Some other things are the formation of a gas or the formation of a solid, which is why you always want to pay attention to the subscript. That tells you what phase it's in at the end. Right? If you have any other questions, just let me know.
All right.
All right.
Thank you.
Thank you.